Without further ado, Nick Mckenna.
All right, thank you. Thank you for having me. All right, so as you said, I'm going to be talking about DNS attacks, past, present, and future. So who am I? I'm Nick Mckenna. I break things. I'm a student. I'm here to talk about some things I've broken. If you want to email me, you can. I'm talking about a tool that I created. It'll be on that GitHub. There'll be a link at the end. All right, so rogue DNS, and that's kind of where this all starts. So rogue DNS, I'm sure many of you know it, but if you don't, it is where you intercept DNS requests and reply with malicious responses. So you try to go to Google, it responds with some other IP. So why it's awesome? Why it's awesome for an attacker? Primarily, it's very quiet, and the main reason why it's the best type of interception attack is because it's low data. So whereas with most types of data interception, you'd have to handle all of the data, which would, if you have lots of clients, that would be, you'd need lots of infrastructure, lots of bandwidth. The nice thing about DNS is it's low bandwidth. You just have to intercept a couple bytes and send back a couple bytes. So it's very easy. The alternatives are very loud, very data intensive. So that's why DNS is pretty great. And that's what kind of caught my eye. So the past and the present. I'm going to be talking about two botnets that did rogue DNS attacks. So the first one, DNS changer. It infected, I believe, 4 million people. It did this by just using like registry calls to change the DNS server of a client. So kind of rather low tech, not very interesting. What they did to monetize it was they replaced ads. So they basically ran their own ad network that worked by intercepting other ad networks. Whoops. Then Soho, and this is what really got me interested in this and what I find the most interesting. So how it would work is it would do CSRF against your router. So it would just try 10.0.0.1 and admin. It would just try lots and lots of default passwords. And it was a little bit more malicious. Instead of doing ads, it would do phishing on bank accounts, like bank pages. It's spread via malvertising, so you'd have a piece of JavaScript that just sends lots of iframes, that sends lots of requests, and it would also sometimes have iframes pretend to be Google Analytics. So this is how it would basically work. So it's spread via CSRF in ads, so just lots and lots of iframes and ads, or just JavaScript loops that would try default passwords and IPs. It would then become your DNS server via DHCP. So your router, it's your router's DNS server. So via DHCP, it will become your DNS server. Then it would redirect, and then of course step 5, profit. So you might not be able to see this very well, but it pretends to be Google Analytics, just a lot of iframes. And then it would also set a secondary DNS server so that I guess they're not being that mean. This is the JavaScript version. It would just try a bunch of different requests. Okay, so the process is, so firmware hacking. So this is kind of getting into the future, but also some stuff that we've seen before. So in attacks like Marie, it is kind of exploiting either vulnerabilities in firmware or just bad passwords. So how this would typically work, you would decompile the firmware, you would look for vulnerabilities, and then you would write an exploit. You would find a way to fingerprint this and then scan. So, so firmware propagation part 2, and this would involve backdooring firmware. And I've seen this attack in the wild, or at least heard of it, but not very frequently. But I think that it will over time become much more popular. So it's where people use either authentication bypass exploits or other exploits to get into a router's web interface and then use that to flash the firmware. And from there, you can put whatever you want in the firmware. So what do you do after that? What is an attacker to do after they become a client's DNS provider? And this is kind of where I started getting kind of creative and thinking about cool things you could do. So, but first kind of a backtrack. So when you think about security and what it means to look at security, you're really looking at largely the difference between how you want a technology to work and how it actually works. And for people like this, man-in-the-middle attacks are seen as something very elite, very hard to do and something done by, say, nation states. But that's not really true. And in looking at how lots of different sites and applications are built, I found that most people aren't really thinking of man-in-the-middle attacks as something that is done commonly or something that's feasible. So for that reason, I built something called DNS strip. And what it is it's a simple implementation of SSL strip using DNS. So it's two parts. It's a DNS server, and then it's a web server. So the DNS server is DNS masks, just because it's very easy to set up, and it's very easy to add manual exceptions. So it's very quick, very easy to install. That's why I used it. The web server, I wrote it in Flask. The main reason, because it's not PHP. And it's good for doing low-level stuff, and you can have a function that is just, when we receive this page, we do this with it. So how it works, I'll get to the demo in a minute. Whoop. So I guess I'll just leave it at this. So I'll show the demo in a second. But what it does is it takes the headers. So it takes the so you send a request to the DNS server. It will respond with the IP of the web server, and then the web server will receive it. It will take the host header, and then it will find its actual IP and send a legitimate request to it. So even if it's an SSL site and it uses HSTS, it will still work against it if you can somehow get them to send an HTTP request to that domain. So here's a demo of that. I'm doing it against Wells Fargo, but surprisingly, it works against every major American bank. Or I guess unsurprisingly. Can we see this? Cool. And it's a little bit hacky in this, so I couldn't get, at the time I did the demo, I broke SSL concurrency. So instead of creating a new SSL session, I just send it to an HTTP site and then intercept it, and then redirect to the SSL site where they would log in again. But it does, when it actually works, it does do SSL interception. So it will create an SSL session with the host and just relay it back to the client over HTTP. Okay, so right here it goes to wellsfargo.com. Up top is the Flash server, at the bottom is the DNS server. So you saw when I went there, it sent the DNS request. Right here, I'm logging in, and then you'll see just the post request here. So typically what would end up happening is DNSSL strip would forward that to Wells Fargo in an SSL session. So you're sending it to the HSTS backed login page, and then it would create an SSL session with it and return the response. But there we go. We took the password from it, my password 1. So that's kind of the gist of it. And it does work against, as I said, every major American US bank. So that's fun. What? Oh, all right. So what's happening here? I kind of explained it some, but here's some diagrams. So the client sends a request to the DNS server. The DNS server sends their response, and the response will be the IP of our Flash server. So then we send a request to the Flash server. The Flash server, and this is the SSL strip aspect of it, will send it back and replace everything that's HTTPS with just HTTP. So then you're sending more and more HTTP requests that it can intercept. Okay, so then the second part of it is intercepting SSL and having your own session so you can play it back. So what we do here, whoops, sorry. And in doing this, whoops, sorry, no. Okay, so what we're doing here is we are sending the request to the Wells Fargo login page, which has, it forces SSL, it's HSTS, although it doesn't implement it very well. After we go to the home page, it responds and it'll say, go to http/their login page. So at that point, we can intercept it. Then the Flash server asks the actual Wells Fargo server, hey, where am I going with this? And then it goes. So then Wells Fargo replies back with the body of, like the HTML body, in its own SSL session. Then it feeds that to the victim over HTTP, so it can continue messing with their traffic. And you can do that indefinitely. So pen test, also known as the future. The reason I'm saying pen test, not the future, is because I guess this isn't supposed to be to be me giving criminals ideas, so pen tests. So what you can do with these type of attacks, or at least what I found interesting that you can do with them. So infecting boxes, and I have another demo, but I didn't have time to include it in this, which is exploiting a vulnerability in apt, where I had a VLAN of like 10 boxes running semi-modern, pretty modern versions of Debian, and then I used a recent exploit in apt, how it signs packages, where you could just intercept a request to, say, the Debian update server, and then say this needs to be patched. Here's where you get the patch, and then it would include malware in it, and it would exploit the signing vulnerability. So you'd infect one router, and then from that you'd infect everything that gets its DNS from that. So you could conceivably use that in a setting like a data center, and I think that would be very interesting to see. If you do that in a pen test, let me know. So full control of all their traffic if you install an SSL cert on their box. So from there you could do certs. You could do SSL signing on the fly, kind of like your own DIY deep packet inspection. And that's if you have an SSL cert on their box. You can kind of defeat this with cert pinning, but not quite. Stealing passwords, kind of like I showed recently, it's pretty good at stealing passwords. Even if the login page even if where the passwords are being sent is SSL and HTTPS, or TLS rather, you can still intercept it if where they're getting the form from is not. So masking the command and control servers, I'm not going to talk about that much, but that is something one could do, because you can just communicate data over DNS, and if it's your own DNS server, you can just retrieve the responses. So, as I mentioned earlier about using DNS, or not using DNS, using apt, your working context would be that you got into a router somehow, and you want to get RCE, and I kind of explained it earlier. So the cat and mouse of this, so kind of what the attackers can do and what the defenders can do. So if you're starting with the attackers having an external DNS server, this is rather easy to block. You can just say, hey, only use these external DNS servers. And lots of places will do that. However, they will not do that with internal DNS servers. So where the attacker could go from there is they could just, if they're already in a router, they could probably flash some firmware that would have its own DNS server running on it that they could do the attack from. And then the blue team from there could conceivably do just monitoring of DNS like that. So monitor local DNS or whitelisting DNS. And then I'm sure that there are lots of red team people that have much better, much more clever ideas than I do. So some fixes, as I said, black hole and external, not black hole, but whitelisting your DNS, monitoring DNS. And then, so the next two are kind of ideas that I've been thinking of, and I haven't seen them implemented anywhere, but I think that they would successfully fix this. And I think it would also be useful for antivirus and browsers to implement something like this. So if you have a bad DNS server and you have, you're sending a request to it and it's sending bad responses, you could look at it, cross-reference a bunch of other DNS servers, and then if none of them give you the same response, you can probably tell that something's up there, and you could investigate that. So I'm working on making an open a DDWRT mod that does that. So if you have a bad DNS server, either being used by a client or by your router, it can look at these and then it can say, hey, this is bad, this is good, etc. So SSL everywhere and always. So as I showed earlier, if you can only really be attacked, at least using HTTP, if you don't use SSL at some point. So if you use SSL always in all your requests, this kind of fixes that. So there are plugins like SSL Everywhere that would be useful for things like this. So proxying, so lots of companies, they will proxy all their traffic out. From there you can sort through it and look at the DNS requests, and you could do something like the cross-referencing I was talking about. So then DNSSL strip, if you want to see more about it or see the code, you can go there. If you have any questions, you can email me there. And that is it. Thank you.
Thank you very much. Oh, before you go, a thank you from BSides and Fitbit. And a thank you from Nick. Thanks very much. We will have another short break, and I will let you know when the next speaker is up momentarily.